a speck of light in the night sky. Mars has long beckoned humanity with its rust-red glow, whispering secrets of a world that once teemed with possibilities. In the past year, our robotic explorers, rovers trudging across its rugged surface, and orbiters peering from above have unraveled mysteries that bring us closer to understanding this ancient planet. Their discoveries, etched in rocks and whispered in chemical traces, paint a picture of a Mars that was once vibrant, wet, and perhaps even alive. These findings don't just rewrite the planet's history, they challenge us to imagine a future where humans might walk its crimson plains on the ground. NASA's Perseverance rover rolls through Jezero Crater, a 45-kilometer-wide scar believed to be the remnants of an ancient lakebed. For over 4 years, its wheels have crunched over dusty slopes, collecting clues from a time when water flowed freely. One of its most striking finds is a rock dubbed St. Paul's Lantern, a fragment unlike any other. This boulder, roughly the size of a microwave, glints with hundreds of tiny spherical grains, some round as marbles, others sharp and angular. Scientists believe these textures formed in a dance of liquid water and violent forces, perhaps when streams carried sediment into the lake or meteorites slammed into the surface, splattering molten droplets that cooled into these curious shapes. What makes St. Paul's Lantern stand out is its floating nature. Its chemical makeup doesn't match the surrounding sedimentary layers, suggesting it was flung here by some cataclysmic event billions of years ago. This single rock tells a story of a dynamic Mars, where water sculpted landscapes and cosmic impacts reshaped them across the planet. NASA's Curiosity rover climbs the slopes of Gale Crater, probing rocks for chemical secrets. In a sample from a slab called Cumberland, it detected something extraordinary: long organic molecules like undecane and dodecane. These carbon-based chains are the kinds of building blocks that, on Earth, form the membranes of living cells. Finding them on Mars is a leap forward. Until recently, scientists thought the planet's organic chemistry was limited to simpler compounds. These molecules don't prove life existed, but they hint that Mars once had the ingredients for it. Were they forged in lifeless chemical reactions, sparked by volcanic heat or mineral interactions? Or are they relics of ancient microbes that thrived in a wetter, warmer Mars? The question hangs like dust in the Martian air, urging us to dig deeper into the planet's past. High above, orbiters like NASA's Mars Reconnaissance Orbiter (MRO) and Mars Odyssey sweep the planet with unblinking eyes. Their instruments map thin layers of rock exposed by eons of wind and erosion, revealing a timeline stretching back billions of years. These orbital snapshots show shifts in climate, from wet epochs to the dry desolation we see today. They've pinpointed minerals like clays and sulfates, which form in water, scattered across ancient riverbeds and lake shores. By stitching together these clues, scientists can trace how Mars' environment changed and identify the most promising spots for rovers to explore. One orbiter image revealed a network of channels fanning out from a crater's edge, like veins in a leaf, suggesting a delta where rivers once poured into a standing lake. These maps don't just guide rovers, they give context to every rock and grain they touch. China's Zhurong rover, exploring the vast plains of Utopia Planitia, added a stunning piece to this puzzle. Its subsurface radar, capable of 80 meters below the surface, detected layered sediments, sloping at a gentle 15-degree angle. These resemble the deposits left by waves lapping at Earth's beaches, strong evidence that a massive ocean once covered Mars' northern hemisphere. This ancient sea, now vanished, likely stretched across thousands of kilometers, its shores bustling with tidal currents. The radar data paints a vivid scene: waves crashing against rocky coasts, sediment piling up in rhythmic layers. Such environments on Earth cradled the earliest forms of life, and the possibility that Mars' shores did the same sends a shiver through the scientific community. Could these sediments hide traces of primitive organisms preserved for billions of years? These discoveries aren't just about the past, they're stepping stones to the future. Perseverance is collecting samples, sealing them in titanium tubes for NASA's planned Mars sample return mission. These rocks, including pieces of St. Paul's Lantern and Cumberland, could reach Earth by the early 2030s. In-lab scientists will probe them with tools far more precise than a rover's instruments, searching for definitive biosignatures, chemical or structural signs of life. A single fossilized microbe or a telltale pattern in the carbon isotopes could rewrite our place in the cosmos, proving that life isn't unique to Earth. Beyond the science, these missions are testing tools for humanity's next leap. Perseverance carries an experiment called MOXIE, which pulls carbon dioxide from Mars' thin atmosphere and converts it into oxygen. In small bursts, it's produced enough to sustain an astronaut for a few minutes, a proof of concept for future life support systems. Meanwhile, rovers are honing autonomous navigation, dodging boulders and craters without human input. These technologies are critical for the day when astronauts land on Mars, needing breathable air and robots that can scout ahead or build habitats. Orbiters, too, play a role, tracking seasonal shifts in the atmosphere, dust storms that block sunlight, carbon dioxide clouds that form in winter. Understanding these patterns will help design spacecraft that can land safely and communicate reliably. The Martian atmosphere, now a wispy veil of carbon dioxide, holds its own secrets. Orbiters have watched it change, thinning in winter as CO2 freezes into polar caps, then thickening as it sublimates back into gas. These cycles hint at how Mars lost its thicker, warmer atmosphere billions of years ago, likely stripped away by solar winds after its magnetic field weakened. By modeling these processes, scientists are piecing together why Mars turned from a potentially habitable world to a frozen desert. This knowledge isn't just academic, it's vital for planning missions where astronauts must survive dust storms or harness atmospheric resources. Each discovery builds a mosaic of a planet that was once alive in its own way, not with forests or animals, but with flowing rivers, vast oceans, and perhaps the first sparks of biology. St. Paul's lantern speaks of water's power to shape rock. Cumberland's molecules whisper of chemical complexity. Jurong's sediments evoke lost coastlines. Together they challenge us to rethink what makes a planet habitable. Earth's story of life began in warm, shallow seas. Could Mars have hosted a similar dawn? The absence of clear answers drives us forward, fueling missions that push the boundaries of engineering and imagination. These efforts also forced us to confront bigger questions. If life once existed on Mars, what happened to it? Did it vanish as the planet dried, or does it linger in subsurface pockets, waiting to be found? If Mars was lifeless, what conditions kept it from crossing that threshold? Comparing Mars to Earth, or even to Venus, which also lost its chance at habitability, helps us understand the fragile recipe for life. Every rock sample, every radar scan, brings us closer to knowing whether we're alone in the universe or part of a larger story. As we stand on the cusp of returning Martian rocks to Earth, the red planet feels less distant. The rover's tire tracks, the orbiter's relentless gaze, and the data streaming back across 200 million kilometers are bridges to a world we're only beginning to know. They remind us that exploration is about more than answers. It's about the courage to ask, to send machines into the void, to dream of boots crunching on Martian soil. Each discovery is a step toward that future, a clue to a past that might mirror our own, and a call to keep searching. Mars, once a distant speck, is now a place we can almost touch, its secrets unfolding one rock, one molecule, one sediment layer at a time.